before them. As a seasoned software professional, Praveen embarked on his journey as a backend developer, crafting robust APIs and ensuring seamless server-side functionality. Little did he know that his path would lead him to fascinating world of data engineering, a transformation that unfolded organically. And now he thrives on crafting elegant solutions for complex data challenges. Whether it's wrangling messy data sets or architecturing seamless ETL pipelines, he finds joy in turning raw information into actionable intelligence. Simplicity amid complexity. Complexity inspires him. He believes that the powerful solutions emerge from simplicity. As a data engineer, he bridges gaps, connects dots, and orchestrates workflows, all while maintaining an unwavering commitment to keeping things elegantly straightforward. Saraswathy is a full stack dev turned into data engineer with a passion for solving data problems and simplifying complex processes. The challenge of designing scalable data principles, migration, and optimizing data workflows and extracting valuable insights from data excites her. As a cloud enthusiast, she enjoys learning and expanding her knowledge through certifications, which helps us stay up to date with the latest tool and best practice in the industries.
Good evening, everyone. Hope you're having fun. So I'm Renu. I'm from Chennai. So I'm a data engineer, currently with John Lewis engagement with the team experimentation.
Yeah. Good afternoon, everyone. Thank you for joining us. So I'm Praveen. I'm from Chennai. I'm a backend dev turned data engineer. I'm currently part of PPRO engagement. The topic for the day is demystifying data warehouse. So for a good reason, there is a lot of buzz around data these days. Data has become one of the most, data is one of the most valuable asset for every organization because every organization is trying to generate insights out of it to make decisions. Yeah. So the agenda for the day is we wanted to briefly cover some of the topics here. What we will do is we will throw a real world example and then try to relate to the data warehouse topic so that it makes a lot of sense. We wanted to throw a business requirement first. So here we have taken New York taxi industry as a industry here. So New York taxi industry is a vital lifeline of millions of people ferrying around New York City every day. So it's an integral part of transportation infrastructure, providing a crucial service. But despite its significance, it faces a significant setback. So we wanted to solve some of the problem that the taxi industry faces. So one of the pressing problem that the industry faces managing fleets and identifying, basically meeting customer demands. So the reason for this problem is because we feel lack of data-driven decisions is actually causing the problem. So what we wanted to do is we wanted to use data to generate some insights so that we can tackle this problem. So we have handpicked two crucial requirements which would help the industry more. So the first one is we wanted to identify what day of the week and time of the day is the busiest hours, and we wanted to understand how weather patterns actually affect the trip. Is there any patterns that is associated with the weather?
Okay, let's start solving the problem. So our goal is to build a dashboard to answer these business questions. Okay, first, what data is required to answer this question? So the primary data that we need is the trip details from the NYC taxi application. So each yellow taxi in New York is equipped with a device which collects information like the time, the date, the payment type, the fare. There was another question about how weather is impacting the taxi pattern. So we need weather data. So NOAA is a US governance agency which gives us these weather data. So they have various ground stations installed. And from those stations, the data like temperature, wind, humidity are collected. So how is the data available for us? For this use case, we have the data available from public data sets. But usually in a real world problem, the data will be behind a secure connection like a database, API, or file drops into a bucket. So how frequently we want the data to be updated? So for this use case, let's incrementally get the data once a day. Example, like a batch run, which extracts all the trip details and weather details for the past 24 hours. And the size of the data, so if we are collecting all the data, it is 1 to 2 GB per day, but for this use case, we are taking only the subset of data. Okay, now we know the data sources. So what is the right platform to onboard this data? So there is database, data warehouse, and data lake. So database is a place where we store structured data, like that is already in the form of rows and columns like spreadsheets. Example, a banking transaction data can be stored in database. And data warehouse also stores structured data, but a huge amount of data, mainly for the purpose of reporting and analysis. And data lake is a huge storage space where we can dump all kinds of data, structured or unstructured, like audio files, video files, messaging, sensor data, mainly to keep it there for processing it later. Okay, how is a data warehouse different from a database? Database generally follows a row-based storage model where all the data for a particular row are stored together. So it is ideal for scenarios where the data is accessed frequently and updated. So it's efficient for transaction processing workloads or OLTP. Whereas data warehouse, the data for column are stored together. So it's ideal for queries where the many records are aggregated to answer business questions with few columns were selected. So efficient for analytical workloads, OLAP.
Yeah. So now let's see what is a data warehouse. A book definition of data warehouse, it is a centralized repository of integrated data sources to support business analysis and decision making. But to put it in layman terms, imagine data warehouse as a specialized database where you can analyze, store, and process data to generate meaningful insights. To imagine, let's take an example. Let's take a large library where books are organized based on the subject. By subject, I mean it can be literature, science, novel. So what's the purpose of subject here? It is so that data can be, the books can be easily retrieved when needed. So now data warehouse is similar to this library where data is stored so that for later retrieval it can be easily accessed. So now that we know what a data warehouse is, let's see what does a good data warehouse means. So in order to consider a data warehouse that is good, it basically needs to be satisfy 4 characteristics. The first one is subject-oriented. Subject-oriented is similar to what I say. Data is grouped based on subjects so that it can be easily retrieved later. The next one is integrated. Similar, again, coming back to the library example, in a library where you would have books from different authors and different publications stored in the same place. So similarly, in a data warehouse, you would have data combined from different data sources so that an organization can have a unified view of the entire company's data in one single place. The next one is time variant. So similar to a library where there would be a system which would track when was a book borrowed, when was a book added or removed. Similar to that, over a period of time in a data warehouse, you would start accumulating historical data. With this historical data, we can sort of try to find patterns and anomalies. These might not make sense on a particular day, but over a historical period of time, these trends and analysis would anomalies would start making sense. So the next one is non-volatile. So in a data warehouse, like the data won't be updated in real time. Like it would be updated because this updated data will be used for visualization in later. So what happens is data would be updated as a snapshot later so that it doesn't affect any visualization or processing that was done at that point. So it is non-volatile. So now let's see when to use a good data warehouse. The first one is consolidate data from multiple sources. By integrating data from multiple sources, as I said, again, like we can have a unified view of the data, making it easier to analyze and understand. Next one is historical data analysis, which is again to identify trends, patterns, and anomalies. Data governance, this is an interesting topic by itself. We will talk more about it in the later slide. Data quality and cleaning, this is very crucial because an organization can't depend on data which has issues with it. So as a part of data quality, like let's say we have use case to correct errors or fix inconsistency, this is where data warehouse is used so that a organization can rely on the data to make right decisions. Then the next one is business intelligence and reporting. This is very crucial. In most of the cases, the end user of a data warehouse would be a visualization tool where you can sort of build charts to understand patterns and help make decisions. Yeah. Let's see some of the common data warehouses available. The first one is Snowflake. Just to give a small brief on Snowflake, it's a multi-cluster, shared nothing architecture, primarily built for scalability and performance. And it's a pay-as-you-go model based on your storage and compute. And Snowflake has very interesting features like time travel, micro-partitioning, and secure data sharing. And the next most common is Google BigQuery. This is a serverless architecture primarily built for with automatic scaling. And unlike Snowflake, it has a flat rate pricing with certain discounts for a very large database. The good thing with BigQuery is it has a lot of integrations with Google Cloud Platform services, and it has good machine learning capabilities as well. And the other common data warehouses are IBM DB2, Amazon Redshift, and Azure SQL data warehouse. So now that there are a lot of options here, it's completely up to us to decide which data warehouse we go. Like it's based on the specific needs, budget, and the technical preference. Yeah.
Okay, now we know what is a data warehouse. So how do we get the data into the data warehouse? The first step is extract. It is basically retrieving data from various of these data sources. And this means finding the right data sources, making a connection to the data source, and accessing the data securely. This also means we have to schedule the extract based on how frequently we want the data to be updated. The next one is transform. This involves cleaning, like handling missing values, fixing inconsistencies, and joining data from various data sources, computing new fields, and enriching the data, aggregating. So all this is transform. Then loading the data into data warehouse and making it available for reporting and analytics purpose. There are two approaches. One is ETL, other one is ELT. So ETL is a traditional approach where the data is extracted and then transformed before loading the data into data warehouse. So historically, ETL emerged when data warehouses were less powerful. That's why there was the need of the external server or compute resource to do the transformation. But ETL is still widely used with the emerge of various ETL tools, which makes which automatically which has connection to various applications, commonly used applications like Jira, Google Analytics, Adobe Analytics. From there, the tool extracts the data, cleans the data, and does some minimum transformation before loading the data into the data warehouse. But occasionally, we still have to do some transformation to answer business questions which are specific to our use case. ELT is a modern approach where the data is extracted and loaded directly into the data warehouse, and then the transformation happens inside the data warehouse using its computational power. So with the rise of cloud data warehouses like Snowflake, BigQuery, it's more powerful. So it's highly it's more powerful. It can handle large volume of data. So ELT is now popular nowadays. And one more advantage of ELT is that with ELT we store the raw data in its virginal form, so it is easy to adapt to new requirements. Like if there is a use case where we have to do another transformation from raw data itself, ELT is a good option. So it's very suitable for dynamic environments where the requirement updates very frequently. Okay, coming back to our problem statement of NYC taxi dashboard, we will build an ELT pipeline. There are multiple stages in the data pipeline. The first one is ingest. As we discussed, we are going to use ELT, so extracting and loading the data into the data warehouse. And then in the raw data, we found some null values, missing values. There were pickup location for a future date, which we have to remove them. And then there were duplicates, which we removed them, and filter only the weather data for the New York City. And then the transformation is like, we have two data sources. Now, two data from two different sources, trip details and weather details. We have to join them by associating trip pickup location with a weather station nearby. So that is done in transformation phase. And then we summarize, that is basically performing aggregations on trip and weather data. So in this example, one of the question was, what is the busiest day of the week? So we have to aggregate the number of trips by week to answer that question. And then finally, visualize, that is building the charts in the BI tool. So the stages that we have seen, right? So each stage corresponds to a layer in the data warehouse. So the ingested data is put in a layer called staging layer or raw layer. And then we clean the data, and the clean data is in cleansing layer. And then we join both the data sources. The transformation happens, and the transformed data is in core layer, and the summarized data in data mart layer. So the data mart is connected to the reporting tool.
So in the last slide, we have seen yet another word with the data suffix, which is data mart. So what is data mart? So data mart is a specialized subset of data warehouse focused on specific business needs and business departments. The data in data mart is just tailored for a particular department, so that it is made easier for them to access the relevant information that they need. So now that we have seen how the data is going to be in the data warehouse, now we will see how we can actually structure the data in each of these layers. So let's see what are the different data models in data warehouse that are mostly used. So now first, what is data modeling? So data modeling is a conceptual representation of attributes, entities, and relationship. It is basically breaking down a large table into smaller tables so that it can be easily accessed and processed. So some of the common data modeling techniques are normalized data model, star schema, snowflake, and one big table. So the first one, normalized data model, is, as the name itself suggests, it is all about normalization. This is very similar to what we do in our database, like 1NF, 2NF, 3NF. We break down and then have relationship between the table. This is well suited for scenarios where you wanted to have a transaction sort of retrieval. The next one is star schema model. This is a very common modeling practice in data warehouse, where your data is structured as facts and dimensions. What is a fact? So fact is basically any metrics or measurement, and dimension is more like a metadata for the fact that we have. This structure is primarily for OLAP systems because this structure can handle large amount of data sets. It can retrieve easily. The next one is snowflake schema model. Snowflake schema model is an extension of star schema model, where here each dimension can have its own hierarchies and subdimensions by itself. For example, let's take a hierarchy like country. A country can have state, a state can have city. So that's the reason why if you see like when extended star schema is extended, it can resemble like a snowflake structure. And this Snowflake schema can, Snowflake model can actually support granular analysis. The next one is one big table data model. This is also again a very common data model. This is well suited for teams when they actually freshly start working on a data warehouse. As the name itself suggests, like you have one big fat table with too many columns. This is well suited in the beginning, but this model doesn't really scale well. Like when too many columns get added, like your retrieval time, or it's a little hard to process. Yeah, again, coming to choosing the right model, it all depends on a case-by-case basis. So we have to weigh the data complexity, query patterns, and performance goals. Based on this, we can actually we can decide which data model that we want in our data warehouse. Let's see a short demo.
Yeah, so this is Airflow. So here is where so this is an orchestration tool where we describe what are our stages and what are the tasks that is going to happen sequentially. So if you see the stages, ingest, clean, transform, summarize, this is what we have seen in the slides before. So the data, so this pipeline actually fetches the data and puts the data in the data warehouse. On the top, if you see, there is a schedule. So there we can configure how frequently we want to schedule the data. On the left side, you see the green things. These are history of runs that happened before. Yeah, this is the BigQuery. This is the data warehouse that we used. So as discussed in the data warehousing layers, so we have one layer for each stage, that is raw or staging layer. Cleansing layer, curate layer, and data mart layer. So the raw layer has the tables, which is in the form of its original way, like how it is fetched from the source system. And the data mart layer is what is connected to the BI tool. So we used a BI tool called Looker Studio. So this can be easily connected to the BigQuery. So now we have the answers for the business question. The first one was, which day of the week are the busiest? So from the chart, we could see that the second half of the week, mainly the Wednesdays, Thursdays, and Fridays are busier than other days. The next one is, which time of the days are busiest? So on Thursday, evenings are more busy than the other times. The second question was how weather conditions affect taxi demand. So if you see the chart, on a mild weather, the number of trips were more compared to a snow weather. And similarly below, on a mild weather, the trip duration is also higher compared to other weather conditions. So there are other charts which gives more granular information.
Now that we have loaded our data into data warehouse and done the visualization, now let's see how we can actually secure the data in our data warehouse. Before going into that, we again wanted to bring in another example to make this more sense. So I guess, I hope everyone would have come across the name Cambridge Analytica scandal. So Cambridge Analytica is a political consulting firm that employed data mining techniques to influence political campaigns. So this scandal erupted in 2018 and raised a lot of concerns around personal data. So a little context behind this scandal happened through an app called This Is Your Digital Life. It is a quiz app where people just answer quiz. What happened in the back is like the Cambridge Analytica, they were able to extract data points about a particular user. Along with that, they were also able to extract all data points from friends who attended the quiz. It was mentioned that around there were 5,000 data points per person was actually extracted, and it was estimated that the Cambridge Analytica had around 88 million people's data. So this was actually used to do targeted political campaigns during 2016 US election and Brexit referendum. Now that this issue has happened, we'll see what was actually missing which could have avoided this problem. Before going into that, we'll quickly see what are the implications of this scandal, and we'll dive into it.
Okay, the first one is loss of privacy. The people became aware that the personal data that we enter in the social media platforms could be used without getting concerned. So, which resulted in loss of trust. And that at the point of time the scandal happened, there was not much of a data protection laws in place which could have prevented this misuse, and which created a reputation damage for Facebook, resulted in reduction in number of users, and they had dip in their shares at the point when the scandal happened. There were legal actions against Facebook. They were fined largely. So Facebook came up with strict policies. They have restricted data access to third parties, and they've also improved the privacy controls for Facebook users. This could happen to any organization. So other organizations started re-evaluating their data governance policies. So what is a data governance? So it's nothing but considering data as an asset and taking efforts to use it correctly and keep it safe from unauthorized access. So the main components are defining the rules and guidelines about how to use the data, how to store the data, how it can be shared within the organization, and assigning roles and responsibilities to people like data owners, stewards, who manage how the data is handled. Data quality management is that implementing processes to improve the quality of the data. Example, having a automated data quality checks in the pipeline before the data is, while the data is loaded into the data warehouse. And data security and privacy, making sure the data is encrypted and all the compilants GDPR is followed. Data access and usage is about who is giving access, under what conditions, setting up role-based access control. Data lifecycle management is about from the data, from when the data is created, and it should stay only as long as it is required and then should be disposed. This could be done by setting retention policies. And metadata management is about having data about data, like a documentation and its data lineage. So this could help other users to give context about the data. And finally, a committee who oversees the data governance program and make any changes to the policies.
Before ending, we wanted to quickly touch upon like some of the future trends in data warehousing. So the first one is data lakehouse. It is a combination of both data lake and data warehouse. Imagine where, as mentioned earlier, data warehouse is primarily for structured data, and in data lake you can have both unstructured data as well. Imagine where you can sort of leverage the warehousing power to perform analysis on unstructured data as well. So this can be achieved through Databricks Lakehouse. The next one is real-time data warehousing. As of now, or at least the common data warehouses that we use, it is not real time. We get the data into data warehouse, process, and then generate. There is always a delay in generating insights. The trend is shifting towards real time, where you can immediately find any anomalies, like let's say a fraud or something like that. You can immediately do. So Amazon with Amazon Redshift streaming, this can be done. The next one is augmented analytics. This is more like where use of leveraging AI and machine learning to sort of help like do data analysis on its own, like where you can use natural language and give prompts to do whatever you want with the data. This would sort of bring non-data engineers to use data warehouse. So Cloud AutoML currently helps in doing that. The next one is data mesh. This is not actually a tool or framework. This is just an approach where data is actually pushed towards the end domains, where instead of having a centralized data team doing everything, it is all about pushing data to where it belongs, so that each team can handle their data and giving a self-serving mechanism to each team so that they can manage things on their own. Yeah, that's it. Thank you.